Hello everyone, Ken here, back with the next installment of the Data Science Fundamentals series. In this one, we're going to break down some of the basic SQL that you would use as a data scientist. Now, you're probably not going to be doing too much database administration, you're not going to be creating too many tables or anything like that. You're mostly going to be using SQL servers to extract data for you to then analyze. So our focus here is going to be largely on writing queries that actually get you the data that is relevant and useful to you. Now, we're going to be using Microsoft SQL Server. You can download it right here. I have the website linked in the description below. You click here. I use this developer version. It is completely free. And you're also going to need Microsoft SQL Server Management Studio, also linked below. You can download it here. That'll probably take 5-10 minutes. If I find a good video on someone showing you how to actually put this together, I'll include that as well. Right here is the layman's baseball database, really good database that we're going to be using and setting up to actually query from. So what you do is, after you've downloaded Microsoft SQL Server, you'll come here and you'll download this 2018 SQL version. So it should be SQL Server Management Studio 2018 or 18, and this one should be 18 as well. So after we get that set up, we are going to open up Microsoft SQL Server Management Studio 18. Which might take a second. While that's happening, you should take the .bak file that you download from the layman's database, and you should put it in this path. So program files, Microsoft SQL Server. This is just where it's accessible. This probably isn't a best practice, but it works for our use case here. So you are going to next open up your SQL Server, and you're going to let me see if I can pull this over. So you're going to use whatever credentials you have here and press connect, and that should give you access to this page here. So I've already loaded in layman's baseball database, but I'll show you how to load in that file. So you right click on databases here, you go to restore database, and then we go to device, and you click these three dots here. You will now go to File, you will click Add, and we're going to find this Microsoft SQL Server folder here. Click that, click this, click OK, and then you click OK here. It'll ask if you want to restore it, and you click OK. Right? So once we do that, it'll be restored successfully, and you'll be able to see it here. So this is generally the SQL. Let me resize this so it fits a little better in this page. Great. Okay, so this is the general, I guess, space that you see when you log in Microsoft SQL Server. These will be where your databases are. If you want to write a new query, you can click there. If you want to execute a query, make it run, you can click here, or you can click F5. A lot of this other stuff, it isn't necessarily super relevant for this basic tutorial, so we'll just jump right into the actual working with the data here. So a lot of the times there will be a database schema that shows how everything is related. I don't believe that this has one readily available, so the best way to evaluate this is to just kind of look at the tables that exist. So tables are like individual Excel files. They have a bunch of columns with a bunch of data and a bunch of rows. So let's look at people, for example. So one nice thing about Microsoft SQL Server is you can right click and you can select the top 100 rows, and that just does a very basic query that gets you the top 1,000 rows and shows you what's in those. So as you can see, this bottom space, which is what's in the database or in this table, looks exactly like an Excel file. So we have the columns with the variable name, and then we have the individual row entries. So people is just a, it's kind of like a placeholder table where you can link up a lot of the different elements. So in each table you have what's known as a primary key. So in this table the primary key is player ID, and this primary key should be unique. So if we want to combine tables later on, that's going to be really important there. Now let's just go through. We have birth year, birth month, birthday, a bunch of things relevant to that. We have their actual name, with their weight, their height, if they hit right-handed or left-handed, if they throw right-handed or left-handed. So in this video, I'm going to walk you through a couple different things. So the first is the basic SQL clauses that you use to get data, which are select, from, where, group by, having, and order by. I'm going to also show you how to get, for example, unique statements or only the top 1,000 rows in a database. I'm also going to show you how to aggregate, so how to get averages, counts, etc. How to do joins, which is where you take a couple of these different tables and you combine the data. And then I'm also going to show you a little bit about subqueries and how to create views. So as you can see, there are these tables here. If you want to create sort of a new table, or like you have a query or something that you use routinely, you can turn it into a view so that you can save it for later on. But right now, let's start with the very basics. We're going to continue with this, what is the table called? The people table here. All right, so let's get started with the very basics here. So to have any SQL query, you generally need at least two things, and that is the select and the from statement. It actually makes more sense to start with the from clause here. So when we do from, we choose what table over here we are calling the data from. So as we see, from Layman Baseball Database, DBO, people. So we're actually getting data from this table in the database. The select clause is used to determine what data to actually pull from that. So in this example query that is auto-generated for us, let's say I just wanted to get a player ID and the birth year. So what we can do, we can remove this top 1,000. If we just select player ID and birth year and we run it again, we will only take those two columns. Now that's pretty nice. If we want more columns, we just keep adding them. I don't really remember what any of those were, so it's okay. If we want to select everything, all of the columns in this database, we would do select star. And there you go. And that has all of the columns there. Now, those two are pretty self-explanatory, I think. So if you want to select multiple, again, you just comma separate them and you do not have a comma at the end. So let's do player ID, birth year, birth month. All right, and then we execute this and it should work. You get those three things. Again, if we just do select star, and I'm going to press F5 this time to run it, then we get all of the different columns here. And in the bottom right here, you can see how many players that they have data for. All right, so now let's move on to the where clause. So the where clause lets us set a condition for our search. So let's say we only want birth years where people were born after, for example, 1990. That means that they'd be, I guess, around 30-ish right now. So we only want players that are relatively young. I'm 30, that's relatively young. So we'll do where, and then birth year is greater than 1990. Let's do greater than equal to. All right. So now, as we can see here, this data is filtered by birth year greater than or equal to 1990. Let's say that we will also want only players that were born in the United States. So we can do and birth country is equal to USA. And there we go. So now we only have United States citizens, basically, born after 1990. And you can keep adding and adding different true-false statements here as you see fit. So now let's say that I wanted to keep some notes in this notebook. The best way to do that is 2 dots, and you can write a 1-line note. If I want to write a longer multi-line note, I do /*, and we can completely note that out. So this does not run. When you try and run this, nothing comes up. So let's say that I wanted to get only the different states where players come from. Or maybe that's not a good. Let's get the individual cities that these players come from, a unique list of that. So if I want to basically remove all duplicates from a query, I do select distinct, and then we would do birth city. So if I could also keep this where statement in there, and it would just filter by that still, but as of right now, let's just run this. So here we go. See, these are all of the unique cities that individual baseball players were born in. And you see there's basically 5,000 of those, which is pretty high. Another quick thing that I think is relevant is the top, like we talked about before. So when we do this select top 100, you can add this select top 1000. You can add this top modifier, and it'll only give you the top 1,000 rows of the data. If you're dealing with huge databases, where there's millions and millions of rows, sometimes queries can take a long time. Using top is a good way to just filter out and see what you're dealing with. Now, the next thing that we're going to do here is we're going to look at a little bit of aggregation. So I'm going to undo this. There we go. So let's just go back to our basic select statement where we get everything here. Let's look at how, for example, weight, the average weight of players has changed over time. I think that'll be kind of a fun way to aggregate and manipulate this data. So what we're going to want to look at here is we want to select birth year, because we're looking at year over time here, and we want to select the average weight. So weight is a command. So when you have a variable that is also command, you can put it in brackets and it will still run. So in order to get this weight, we have to group by something. So we have to group by birth year, so we're only looking at year and weight. We're ignoring all of this other data. So we're going to do this group by clause, and then we're going to do birth year. So what's going to happen is we're going to aggregate all of the rows that are by birth year. So we're going to take all of the 1981 columns, and we're going to average the weight for those. All right, so let's see what that looks like. Nice. So as you can see, it should have unique values for each of these columns, but they're all out of order. So what we can do here is we can order by, which just sets the order by a certain column. So we're going to also order by birth year, and we're going to do this ascending. So, it looks like people are pretty light in 1838. Not sure what that one's about, but it looks like there's a general trend of increasing weight in baseball players over time, which is pretty cool. Maybe in 1998, when the players are relatively young, they're still in their 20s, they haven't fully matured yet, so their weight is a little bit lighter as they've gone up there. But this is a pretty cool thing, if you ask me. So if you want to re-alias, so like right now this is just called weight, we can say as average weight, and it'll give this column the name average weight. There we go. So if you're like, okay, well, you know, what years have a weight greater than maybe like, I don't know, let's say like 170. Since we grouped by, actually, let's say, so instead of average, let's do a count, right? We can get the number of people in each year. So this year, it looks like they have 0 people. That's why they were getting nulls there. So let's say we only want years that have basically 100 people or more, all right? And the average for that. So we're going to do average, and then we're going to use this having clause. So having is like the where clause, but it lets you filter a group by statement based on a aggregated criteria. So we're going to say having count of weight greater than equal to 100. So now we run this. We should also probably have, just so you can see it, count weight. Perfect. So as you can see, none of the people here, or none of the years here, have a count of less than 100. So this is a great way. This is how you aggregate. So you don't just have average, you can also use sum, you can use min, you can use max, and you can use count. There's probably something else that I missed there, but if you're looking to aggregate this data, you do that by using this group by clause. Okay, so now we're going to move on to joins. So joins are important if you want to combine the information in multiple tables. So let's take a look at this batting table here. So as you can see, we have the player ID and a lot of these batting stats, but we don't have the actual player name. So we want to join basically the player name so that we can see it along with this data. So in SQL, you have a couple different types of joins. So let's just look at what those are. So see if I can find a decent visual here. I like this one. This one, I've seen this before. So you have an inner join. Let's see if I can't blow this up a little bit. Okay, so we have an inner join, which is basically taking only variables that are in both of the two data sets. So there's no null values. A left join is you take all of the data from your first table and then append only the data that's relevant in the second table. So you can still have values from the first table that have null values where the second table columns that are added are. A right join is the exact same thing as a left join, it just goes the other direction. So if you were to do B left join A, that is the same thing as a right join. I'm not really sure why they have two, it should just be called a side join or something. So an outer join, it takes all of the data from both, and so you have all of the columns in both A and B, but there are null values over here where there isn't any overlap between the variables there. And then I guess you can do a left excluding join, which basically removes from A all of the values that are in B. Same thing with these. And then you can do an outer excluding join where you only get the data that is not in both A and B. So those are the basics here. I really only use inner joins and left joins. Those are kind of the most practical in my mind. With that being said, we are going to use an inner join to join this batting and the people tables here. So let's create a new query, and so we're going to select. So right now we're just going to select star as a placeholder. So from dbo.batting, let's just see what that looks like real quick. Okay, it runs. We're also going to select star from dbo.people. So our job is to combine these two together. So the first thing that we need to do is alias these, and you'll see why we're going to do that later. So we're going to do dbo batting as bat, and we're going to do as people. We're going to call it PO. Okay, so now when we actually are identifying the columns, we can put an identifier in front of that. So both of them have player ID, and it'll be ambiguous which player ID we want to show in our new data set. So we have to alias like this. So below I'm going to actually put the query that we're going to write. So we're going to select star. We're going to select actually bat.star. So we're going to select all from this batting table, and then we're going to select p dot let's see, what did that look like? Name first, name last. So name first dot name last. So we're going to have all of the batting data, and then the person's first name and the person's last name. And then right here, we're just going to copy this in. And so what we do is we're going to do inner join, and then we're going to take this second statement here, and then we're going to inner join them on bat.player ID. So remember, this is that unique identifier that is in both of the tables, and we're going to set that equal to peep.player ID. So let me just comment this out real quick. So with this type of join, you should be able to see if it runs. That does not run. Incorrect. Oh, I need on. Oops. Okay. There we go. So as you can see, we've joined the player ID with the actual name. So all of these are attached there. The rest of the query works exactly the same. So you can do where. Maybe we do at bats. You can alias at bat, or if it's unique like this, like there's no at bats in the people column, you can just do normal AB greater than 100. Great. So again, all these at bats are larger than 100 here. So let's also do a quick version of a left join just to show you how that can be relevant. So let's look at this pitching column here, and let's try and join the player ID based on the year to the batting table. So there are some pitchers that obviously hit, and we want to see who those are and see nulls in those other columns. So let's create a new query, and so we want to select star from dbo.batting, right? Oops, capital, and select star from dbo.pitching. All right. Great. So we have these two tables, and we want to join again on the player ID. but also on the year, not birth year, on the on the year ID of that season stats. So we are going to do, okay, so we're going to select, we have to alias these again, so add that as pitch. So we want to just select, we're going to use all the data this time, so we're going to just select star bat dot star comma pitch dot star from this guy, and then we're going to enter join. You don't have to do the spacing here, it just helps me keep things in place. In theory, as long as you have the clauses, you can put it all in one line or in any way that you want here. So on that dot player ID is equal to pitch dot player ID and that dot year ID is equal to pitch dot year ID. So we can join on multiple things, and for this it's important to join on multiple things. Otherwise you will get this kind of one-to-many relationship where it'll really explode the amount of data that you have, which we do not want. So again, let's kind of see if this works. And that was my bad. I said I was going to do a left join, so let's do that. You also don't have to do it in caps, but that's just like the way I learned and it looks cleaner to me. So let's see what this looks like. So perfect. So as you can see, a lot of these players who did not pitch will have a bunch of null values, and that is what this this left join will cause if the batter did not have any pitching data. Again, if we wanted to do a right join, which is the same thing as just doing a left join and putting the pitcher first, we would get the opposite, where we'd get pitchers with all of the data and the batters with very little data. Okay, so we're kind of nearing the end here. There's just two more things that I want to show you how to do. So the first is subqueries, and then I'll also show you how to create a view, which is just, it's very much like creating another table for you to work with, but it's less of the, I guess, database overhead, and it's easier to delete. Yeah. So let's start with a subquery. So let's say that I wanted to figure out, which pitchers that had over, over 10 wins also had over, 30 at-bats. So the way that we would do this, we'd use a lot of the same query. So let's just comment this out so we have it. And I apologize if there's some construction noise in the background. I'll try and edit that out as much as I can, but that might be a little bit unlikely. So we can leave this very much the same, but we can also just create an additional query that can filter some of these out, some information out. So let's say we want to just look at, again, select star from DBO dot pitching. Come on. Where what I said, wins greater than or greater than or equal to 10. So we can actually take this whole select statement and put it in there instead of this DBO pitching. So we can do this. Okay. So now when we do this, we're already filtering for pitchers where wins are greater than 10, and I changed this left join to inner join. So we will get, I haven't filtered for the at-bat number yet, but if we run this, inner join, as pitch, so I didn't alias it. Alright, so now we get pitchers here where the wins are greater than 10. And then now if we want to filter this by the number of well, it looks like almost everyone has over 30. So let's do over like 40 at bats. Now we can use this where clause. No. Oh, I take that back. A lot of them have very few at bats. Yeah, we'll still do 40. AB is greater than equal to 40. Cool. So now we have pitchers who have more than 10 wins in a season, and they also have more than 40 at-bats. So again, this right here where we're putting a query inside another query in the from statement is called a subquery. That is not always the most efficient way to do things, but sometimes it is the only way to do things. So you'll see this a reasonable amount where you, for example, like group by something. So you want to group by the number of, you want to group by individual players where they're unique, and then you join it back. That is generally the best use case where you're trying to filter something out through a join. Okay, so the last thing I want to do is to show you how to create a view. This basically lets you save a query as a table, and then you can join on that view later on if you want. So let's just create a very simple view. For this, we're just going to do pitch, and then we only want wins now. So let's see what that looks like. Again, it just includes the wins of the pitcher. Everything else is the same. It's just chopping off the rest of those rows. This SQL query is still being joined there. So we want to create a view. It's pretty straightforward. So we create view, and then we'll call it winning WINNING pitchers as, and then we should be able to just run it. So it says it's created successfully. We can go here, and then we have this DBO winning pitchers. We select the top 1,000 rows, we get that exact same thing here. Now, I can now write a query that I use this in the from statement, and I can join to that or do anything like that. It's effectively the same thing as using a subquery, except it's a bit more formal and you're saving this view here. So those are kind of the basics. Again, we went through the different clauses, select, from, where, group by, having, order by. We also looked at distinct and top. Then we worked on aggregation, showing you how to use the group by and having clauses specifically with count, average, sum. I think you could probably do median too, something like that. Next we looked at joins, subqueries, and then finally how to create a view. So that should be hopefully all of the basic SQL stuff to really get you started, to help you either with kind of the job search here, to show that you understand, again, the basics of SQL, or this can help you maybe even get started with building and querying your own database. So again, I hope this is useful, and I really appreciate you watching this till the end. If you want to go through and look at any individual sections in the description, all of these are timestamped. If you have any questions, please leave them below. And until then, good luck on your data science journey.